Hello viewers, in this lecture we're going to be teaching you friction. Now this friction is related to class 11's physics book. It is also present in class 9's physics book, but the main topic of this lecture would be related to class 11's book. Now first we should be known that what is friction. Now friction is the force that resists the motion. Now what does it mean by the resisting motion? Resisting motions means opposing the motion. Now just suppose that this is a body. Now this body is moving forward. Now the body is applying force forward, but the friction that is resisting the motion is in the backward direction. Now this opposite direction or the opposite force is known as friction force. Now example of frictional forces can be traction needed to walk without slipping. That means that should be a rough surface to just walk may be beneficial. But they also represent a great measure of opposition to motion. Now we know we should apply more force in more rough surface and less force in less rough surface. Now the best example of that can be the friction here. Now we know that this place is little bit curved. Now the body should apply little bit motion or little bit force to just displace from this point to this point, because there is less roughness of the surface or the direction of that surface is little bit curved, which makes it easier to get a motion. Now when this body reaches this surface, it starts to move slowly. Why? Because there is more roughness and more friction. Classical and modern theories on friction. Now we know that there is theories on every topic. The one theory can be the old one and second one can be the modern one. Now as well, friction also have two theories. According to old view, the roughness is the cause of friction. But we know that, or according to the modern view, the friction is the force that is produced when two objects came in contact. That can be atom to atom, molecule to molecule. We can say that the attractive force or opposing the force is known as friction. Roughness of the surface can increase the friction, but that isn't the cause of the friction. Now, the types of the friction. First one is static friction. Now, the word static explains itself. Static means at rest. When a body or the surface is at the rest, that friction produced by the object is known as static friction. Now, the example of static friction can be this body placing on a surface. Now, there is three forces acting upon it. The force which held it to move forward or which will be applied. The normal reaction which caused as the reaction of the weight, that is mg, caused by the gravity. Now these three forces are acting upon a body. Now when a body is at the curved position, there are approximately also three forces acting upon it, but there is a fourth force, that is friction force. Now body here is also in rest, but there is a friction force acting upon it. The friction force here would be considered as limiting friction force. Let me explain you in detail. Just suppose the limiting friction force is the maximum value in a static friction. Now the body is just about to move, like it is going to move, but the condition before moving is known as limiting friction, or friction before the moving is limiting friction. Now we can calculate the elasticity of the friction by simple sum formulas. That formula is Fs. Now here Fs is the static friction that is equivalent to the mu, that is coefficient of friction, and n, that is normal friction. N is also denoted as R sometimes or in the upcoming derivations. The kinetic friction, that's the second type of the friction. Now there is two forms in kinetic friction. Now we know that the kinetic words means motion. When a body is in motion, the friction in that body can be termed by two definitions. The first one can be the sliding friction, when a body slides over another body, and the rolling friction, when a body rolls over another body. Now you will be confused that what's the difference between the sliding friction and the rolling friction? Now there is a huge difference between it. Now when a body slides over another body, all of its x-axis, or we can say that all of its lower part is connected to the or in contact with the surface, or it makes a proper angle. Three forces are acting upon it, and there is an angle of friction also. Now angle of friction, limiting friction, we are going to discuss in upcoming videos. But for now instance, we can just describe it as when the body's lower part is in full contact of the surface, it is known as sliding friction. But in the case of the rolling friction, only some part of the x-axis is in contact with the surface. Now rolling friction is always between the sphere or circle form. Like the body when is in a sphere or circle form, this is known as rolling friction. Or we can say that when a body is in the condition that is it is moving in this condition. This is the surface. It is just moving in this condition in which its perpendicular area is touching the surface. Now that is also called rolling friction. But that is very rare condition, so it is not termed. Mostly it is just considered that the sphere or the wheel or the tires can be doing the rolling friction, or by the help of the rolling friction we can easily drive a car. And that's all about today's lecture. No, that's not all about today's lecture. There are also laws of friction. Now we know that the frictional force is opposite to the relative motion. The force we applied is at the forward direction, and the frictional force is always in backward direction. Or if we are moving in backward direction, the frictional force is in upward direction or the forward direction. The frictional force is parallel to the force in contact. Now we know that the frictional force we are applying just opposes it, or we can say that it is opposite to the force applied to the surface. The frictional force is directly proportional to the normal force. Now we know that the normal force is directly proportional to the frictional force, because when a body is being applied to a normal force, it means that the body has more mass. So the more mass, the more friction, the less mass, the less friction. The frictional force is independent of area of contact. Now here there is differentiate between rolling and sliding, but we can't say that if a wheel is rolling over a surface, so how much axis it should be. There isn't an appropriate value for that. So the frictional force is independent of area. The frictional force depends upon the nature of two surfaces in contact or their state of roughness. Now we know that the more the roughness, the more the heavier the object is, the more the frictional force is. The kinetic friction of relative weight, velocities of their surface. Now we know that as more the body is moving, the more the velocity would be, the more the frictional force would be. And that's all about today's lecture. Thank you.